imagine an infinite emptiness. In this emptiness, there are no objects. There is only you. And there is a rock. Let's call it rock A. You are standing on rock A. And you see another rock. Let's call it rock B. Rock B is moving away from you. Moving away from a constant velocity, v. Now imagine you leave rock A and start to move towards rock B. Let's imagine you very gently get onto rock B. Now what do you see? In relation to you, rock B is stopped. And you see rock A is now moving away from you. Moving away from you at a constant velocity v. Now, out of these two rocks, which one is actually moving? Which one is moving, passing the space around it? If you had watched the introspectum part 1 video, you know the answer is there is no such a stopped space. A moves in relation to B and B moves in relation to A. And that is all. There is no absolute velocity. In other words, there is no velocity in which objects go passing space. That is the nature of emptiness. Now, does that mean empty space means just nothingness? Okay, let's imagine you tied up rock A and B with a cable. Let's take you out of this picture for a while. This instrument A connected to B with the cable start to rotate. What do you experience? You will see there's a slight tension developing in the cable that connects A and B. As the speed of spin increases, you will see this tension of the cable increases largely. If this instrument stops rotating, then there is no tension in the cable. Now, if the empty space means just nothingness, and if there is nothing around this object, in relation to what does this object is rotating? Why it is developing a tension in one condition and not in another condition? This shows empty space is not just emptiness. It is same with acceleration. There is a non-rotating and non-accelerating empty space. There is no non-moving empty space. To understand and do math on this space, we need a system of measuring it. The tool we use is reference frame. For example, imagine you sitting on rock A. To describe your observations, we define a coordinate system in relation to you. This is your x-axis and this is z-axis. When time is t1, B is here with reference to your coordinate system. When time is t2, B is here. So in relation to your reference frame, we can calculate the velocity of B. Reference frame is the first concept you need to understand. The second concept is the frame of inertia. Imagine A is a container, a closed container. That means you can't look out. You are inside A. Here is the reference frame of A. Imagine B is identical to A. In relation to A, B is moving at a constant velocity v. If we take you out from A and put you inside B, what difference can you notice in B? Whatever the experiment you do inside B, you cannot find any difference to A. The laws of physics are the same in A and B. Now, if B is accelerating in relation to A, you can notice the difference of behavior of laws of physics. If A and B are not accelerating in relation to each other and not rotating in relation to each other, then the laws of physics are the same inside A and B. So this is called the frame of inertia. So we call A and B are in the same frame of inertia. So here A and B are either accelerating in the same manner or not accelerating. Whatever the experiment you carry out in A, the results are identical to the B. There is no difference between A and B. So A and B are in the same frame of inertia. Here, B is accelerating in relation to A. Therefore, the behavior of inertia in B is different to A. In B, everything you release gets accelerated towards this direction, as if there is gravity. In A, everything is floating. So here, A and B are not in the same frame of inertia. So once again, there is a non-accelerating space. There is no non-moving space. This idea that there is no stored space around us was challenging, especially with the Maxwell's equations of electromagnetism. Maxwell's equations suggest the speed of light to be a constant. If the speed of light is a constant, then there has to be a medium in relation to which it is constant. This medium that is imagined to permeate through all space was called ether. If there is such a medium, then the galaxies must be moving in relation to that medium. Our galaxy, our solar system, and our planet must be moving through this medium. There is hardly any chance that our planet is stationary in relation to that medium. So if we measure speed of light in different directions, we should get different values. This is what they did in the Michelson and Morley experiment. And whatever the direction you measure, speed of light was the same. If by chance at the time they measure the speed of light, Earth is exactly stationary in relation to the medium, surely it shall show different results in 6 months' time when Earth is moving in the other direction. No matter when or where you made measurements, speed of light was the speed of light. So there's no medium. There's no stopped space in and around us. Speed of light is the same in all reference frames. This is quite puzzling. To understand how puzzling it is, let's do a different diagram. The space is one-dimensional. Vertical axis represents time. Let's say you are standing 1 unit away from the origin of this coordinate system, not moving. Then this is your trajectory. Your position does not change in relation to time. This is the trajectory of a light ray. X increases as time passes. If you measure time in seconds and x in meters, this will be a very horizontal line. Therefore, to make our calculation simple, we choose the units of length in terms of light seconds. So if t is in seconds, x is in light seconds. If t is in years, x is in light years. So the speed of light is 1. Then this is the trajectory of a light ray. If now the time is 1, if right now the time is 1, then this is you receiving a light ray right now. Let's say this is your friend. This is your friend receiving a light ray once again right now. Both of you receive a light ray right now when time is 1 simultaneously. Let's look at this seemingly simple common sense concept of now. The concept of simultaneity. To understand things little more clearly, let's look at a different diagram. Here are 3 friends standing at 1 unit distance from each other. They are standing still, not moving in relation to each other. A, B, and C. Let's think the middle one is you. Each one of your friend is holding a flashlight with them. When time is 0, each one of them are going to send you a light signal. Let's draw a space-time diagram for this. This is x-axis, this is t. This is your friend A at origin, x equals 0. This is the trajectory of a light ray sent by him. And this is the trajectory of the light ray sent by your friend C. And this is you receiving both light rays when time is t1. Of course, this is a quite simple diagram. So when you receive light ray at time is t1, you know they have sent it when time is 0. You can calculate it. It is quite simple. The question is, If the speed of light is the same in all reference frames, how does a moving observer sees this? Let's think this is me. I am moving passing you at a velocity v. If the speed of light is the same in all reference frames, how do I see this? Let's do a space-time diagram for this. This is my reference frame. This is x, this is t in relation to me. This is how I see it. According to me, this is the trajectory of A. X equals Vt. A is moving away from me at a velocity of v. So therefore his trajectory is x equals Vt. This is trajectory of you. You are standing 1 unit away from the origin. Therefore, your trajectory is x equals Vt plus 1. This is the trajectory of your friend C. 2 units away from the origin, therefore x equals Vt plus 2. So what would be the trajectory of the light rays sent by A to you? Since in all reference frames light travels in the same speed, this is the trajectory as I see from my reference frame of the light ray sent by A. The trajectory is x equals t. So this is you receiving that light ray according to me. You receive the light ray sent by C at the same time. So let's say you received the light ray at the same time right here. So then when has he sent this light ray? The trajectory of that light ray has to be x equals minus t plus some constant. Since the light travels in the same speed in my reference frames, the trajectory has to be x equals minus t with a constant. The question is, what is this constant c? And if this is the trajectory, at what time has c sent this light ray? Let's name these points as P, Q, and R. Now, what are the coordinates of point Q? X equals Vt plus 1 and x equals t goes through point Q. So at Q, we can solve for the x and t. X equals Vt plus 1, x equals t. So let's substitute t as x in the first equation. Then x equals Vx plus 1. So x times 1 minus v equals 1. Therefore x equals 1 over 1 minus v. Since x equals t, t equals 1 over 1 minus v. Then x equals minus t plus alpha. This light ray goes through Q. So we can now solve for alpha. Let's substitute coordinates of Q to this equation. So x equals minus t plus alpha, 1 over 1 minus v equals minus 1 over 1 minus v plus alpha. So alpha is equals 2 over 1 minus v. Now since x equals minus t plus alpha and x equals vt plus 2 intersects at the point r, we can solve for the coordinates of r now. X equals vt plus 2, this is equation 1, and x equals minus t plus alpha. Alpha is 2 over 1 minus v. So let's deduct equation 2 from equation 1. Then 0 equals v plus 1t plus 2 minus 2 over 1 minus v. So we'll multiply everything from 1 minus v and we get 1 plus v times 1 minus v t plus 2 times 1 minus v minus 2. So it becomes simple. 1 plus v times 1 minus v is 1 minus v squared t plus 2 minus 2v minus 2. So 2 cancels off. 2v equals 1 minus v squared t. So t equals 2v over 1 minus v squared. Let's quickly substitute this to the equation 1 and solve for x also. So x equals vt plus 2. We'll substitute t with this. So x equals v times 2v over 1 minus v squared plus 2. We'll combine denominator for both. So 1 minus v squared 2v squared plus 2 minus 2v squared. So 2v squared cancels. So it simplifies. X equals 2 over 1 minus v squared. So xr equals 2 over 1 minus v squared and tr equals 2v over 1 minus v squared. So look at this point r. This tr is the time when your friend C sends the light ray. To get a feel of it, let's imagine my velocity in relation to u to be 0.5 times the speed of light. Let's take the units of measuring time as minutes. So tr equals 2v over 1 minus v squared. When v is half, 2 times half over 1 minus half squared. So we'll take 4 denominator common to both, then 4 minus 1 divided by r over 1 equals 4 over 3. So 1 and 1/3. 1 minutes and 20 seconds. So according to you, A and C sends the light rays simultaneously. According to me, C sends its light ray 1 minute and 20 minutes later. What is happening right now simultaneously for you is 2 different times for me. Which one of these 2 observations is the reality? Which one is the illusion? Now, thus in reality they happen simultaneously, and I see an illusion of them happening in two different times. In future videos to come, you will learn none is an illusion. Both are real. What happens simultaneously really to you in your reference frame are things really happening in two different times in relation to my reference frame. And that is the nature of reality. There's no one particular absolute now, an absolute present moment. Einstein once said, the sharp difference you see between past, present, and future is a stubbornly persistent illusion. This is time you see. It's a line. This is past and this is future. This is present moment. This is your birth and this is your death. And this is you right now, right here. This is the present moment. And this is the direction of the flow of time. In videos to come, we will elaborately see why this time you see is an illusion. When the flow of time and present moment you see are illusions, then the existences you see are illusions. Because things exist in present moment. When existences you see are illusions, you that you see is an illusion. Think about it. The most obvious thing that you know, the most important thing that you know, that you exist. It is an illusion. Introspectum is a platform for you to methodically understand this reality. And it is going to be the most important thing you have ever known. Subscribe to this video channel, as this is going to be a comprehensive course on special theory of relativity, covering all aspects that requires you to understand nature of time. In next video, we will discuss time dilations, length contractions, and Lorentz transformations.